In example 3, we are going to use what's called the zero product property to try to solve the equation for x. And what the zero product property tells us is that if you have two factors, a times b, and you want the result to equal 0, that means that either a equals 0 or b equals 0. So our goal in solving these problems will be to try to get one side of the equation equal to 0. For example, in A, I'm going to subtract 42 over to the left side from the right, so take away 42 from both sides, leaving this 0 over here, and this will allow us to use what's called the zero product property. So if we can break this expression down into its two factors and set it equal to 0, we'll be able to solve the problem because we'll have an x plus 7 times an x minus 6. And since these are being multiplied, it's very similar to having a times b equals 0. So either x plus 7 has to equal 0 or x minus 6 equals 0. So the two numbers that are going to actually solve the original problem here will be x equals negative 7 or x equals 6, because 6 minus 6 equals 0 and negative 7 plus 7 equals 0. So these are the two solutions to this problem, example 3a. In part B, it's very similar, except you have multiple items to bring over to the left side. We're going to add 9x, and we're going to subtract 5 over to the left side from the right, leaving a 0 on the right. Now we have like a second tier difficulty type of problem here to factor, where we have a 2 in front of the x squared. So instead of just an x and an x in these two spots, one of them is going to be a 2x and the other one an x. Then I'm missing a factor here and a factor here that multiplies to make negative 5. So we have some options, right? We can have a negative 5 and a positive 1. We could have a negative 1 and a positive 5. The 5 could be over here, and the negative 1 could be there. So we have some trial and error to do. And my thought process involves, positioning the 5 so that when I multiply the outside, I'm thinking about foiling as I'm factoring. I'm thinking about what these outside numbers or factors would multiply to. I think if I put the 5 here, I'm going to get a 10x. And the 1 here, I'm going to get a 1x. And that'll help me get the result of 9x that I want in the middle. In fact, I want it to be a positive 9x, so I'm going to make the 5 positive to make 10x, and the 1 negative to make minus 1x. 10x minus 1x is 9x, so that looks like a pretty good factoring job right there. What we have to do now is we have to set both of these equal to 0 and solve for x. X equals negative 5 is one solution. Set 2x minus 1 equal to 0. Add 1 to both sides. Divide by 2. X equals 1/2 is the other solution. Hey, so what you could do here now to check your work, think back to what we did in Unit 1. You could take 2x squared and put that in for y1. You could take negative 9x plus 5 and put that in for y2. And you're going to have a parabola and a line. And I bet you if you find out where they intersect, you're going to be able to confirm these answers. You'll confirm that they intersect at 1/2 and negative 5. And that'll confirm your answers so you can see if you did a good job there. You could do the same thing with a. You could put x squared plus x in for y1 and 42 in for y2. And for that one, you're going to have to play around with your window a little bit to ensure that you can see where they intersect, because 42 is going to be way up off the screen on a standard window. All right, so that's example 3. A and B, I'd like you to follow it up with doing the 2 try-its on your own.